Well, hello everyone, and welcome back to Adrian's Digital Basement 2 Super Mini Mail Call. As you are aware, because you're clicked on the icon to watch this video, we have a package here. This comes from Walter in Dingman's Ferry, Pennsylvania. Hi to all my Pennsylvania viewers. Opening the box, there appears to be a whole bunch of stuff in here. All right, let's see what's in here. I got to unpack all this. So there is a plethora of stuff on the bench, including something that has a laser logo on it. Laser. And I don't know, everything is really nicely wrapped. Right off the bat, we have a Kingston chip lifter. You stick this under a PGA pin or PGA processor, that is, or whatever chip, tilt it that way, and it lifts it out of the socket. Very cool. We have a sticker here that was just loose in the box. Works with the Apple II GS. So we have probably some Apple II stuff here, but we definitely have some PC stuff because this appears to be some kind of a processor upgrade. So a Kingston turbo chip, and almost certainly that was what this was from. So that looks like some kind of a processor upgrade. Not for resale. That's fascinating. I'm thinking that's a 486. That looks like a 486. And we can see a surface mount package under there. System pin 1 up there in the corner. Got a voltage regulator, and well, what is the turbo chip from Kingston? I do have to wonder. So the Kingston turbo chip came in an upgrade package to boost a 46 to a Pentium 75 performance, hence AMD named the CPU the AM586P75. Yes. So you plug it into your 46DX33 or 25, I guess, you'd get less speed, but if you have a 33 megahertz, then it would boost it up with a multiplier, or 4x multiplier to 133 with a bunch of cache memory and stuff. And this web page here seems to have some benchmarks that were run. Where does this chip fall into things? No, it's not a K5. It's going to be way, way, way down here. There it is. So it's not even as fast as a Pentium 16. Obviously, the math speed is going to be far slower, but it is faster than a DX266. So it is a little bit of an upgrade over that. Although with the DX4100, you have to get an overdrive one because you couldn't just stick a DX4100 into a normal motherboard designed for a DX33. You could, on the other hand, put in a DX266. That was a very common upgrade path, and maybe even the DX280 if you increase your front side bus to 40 megahertz. This was definitely just a drop-in replacement, and if we find the DX33, there it is. So it would be that big of a bar. I mean, you know, it's a significant power or speed increase. Not nearly as fast as like an MMX 233 though. Look at that huge performance increase over this stuff down here. But anyways, very cool. I love stuff like that. This will have to be for a future video though, where I test this out and we can do some benchmarks on it. Because it looks like Walter has sent in a ton of super fascinating stuff. So this looks like a socket something cooler. Maybe for like a Pentium 4, I'm thinking. So we have an Intel badge on there. So this thing is definitely Pentium 4. I really don't know much about Pentium 4. I never had one, actually. I was an AMD person at that point. I still use AMD, actually, to this day. But there was a while I was using Core i, whatever, Intel stuff. But I've since gone back. But yeah, this looks like a Pentium 4, I would think. Digitech Expander card series. What is this? Looks like the card got shifted a little bit, but I am going to wager that that is definitely an Apple II card of some kind. And it looks overexposed, but there's nothing to read there. This is a Super Printmaster 3. Got a little bit of corrosion there. This transistor is kind of bent over. Let's try to straighten that out a little bit, just to make sure it's not shorting or whatnot. Okay, that looks okay. So the box that this was in was obviously the original box. This would have had a cable to go to your Centronics printer. So parallel printer interface cards were pretty common for the Apple II. Lots and lots of companies made these. Mainly so you weren't stuck by using like Apple's expensive printers. You could use Epsons and other things like that. Patent pending, Digitech International Incorporated. I am not familiar with these guys, the DK30-4. Part of that is because parallel printer cards, you know, aren't super interesting. And to be honest, one of the things that we don't have is the cable, unless it's in one of these other packages here. Because to hook this up, you do need that Centronics ribbon cable, and it's not always compatible from one card to another. We have an SMT Printech II parallel printer interface card for the 2 Plus and the 2E. Includes a 6-foot pre-tested cable included. 3-year warranty, another printer interface card. Kind of boring. And unlike the last one, this one has the cable. Let's see if this is something that you can remove. It's a very long cable wrapped around the card. Oh, look how simple that is. Not a lot going on with this one. The Printech II. It's my thought this is probably a PROM, a programmable ROM chip. So this is like 256 bytes, something like that, very small, kind of like an EEPROM. And then just some simple logic, select logic and whatnot. And that's it. So theoretically, we could actually test this out, or when I go around to testing this, not in this video, I could try this cable on the other card. I think I might have a few other printer cards as well. Almost certainly these just work. Parallel printer cards like this are very, very common. In fact, when you look on eBay and you're looking for Apple II cards, you know, prices vary from what you're buying, one card to another. But what's always super cheap and very plentiful are printer interface cards. Lots and lots of Apple IIs have these pre-installed in there because people needed to print and they were using like an Epson or Star Micronics or whatever insert parallel printer. Therefore, you needed a card like this to use those printers. And the fact is there aren't that many chips on here. So these were relatively inexpensive, at least from my recollection. Now this one also has a manual in here. The Printech II instruction manual. Looks like this company was based in San Marcos, California, almost certainly long, long gone. Systems Manufacturing Technology Incorporated. I'd say that one of the most popular cards for the Apple II for parallel printing was the Grappler card, and they made a whole line of them. And there was another one called like the Fingerprint or something. I think you touched a button and it would print your screen automatically. That was a pretty popular one, or at least they advertised it a lot in magazines, things like that. There's really not much to this. Put it in slot 1, PR number 1, kind of gives you a little bit of info on how to print stuff. This line will print, that line will not print. Yep, and then PR number 0 to turn off the printer. That little PROM that we saw in there, that small IC, that was the tiny little ROM. That facilitated you typing PR number 1. That gave the Apple what it needed to be able to print to this when you did PR number 1. It's pretty nifty that Walter had this in the original box, just like this other one here. Okay, so carefully wrapped up in this foam is an Apple floppy drive, and this is one of the 3.5-inch ones from the Macintosh. And judging by the fact that this is MFD51W03, I think this is an 800K disk drive, so double-sided, double density, 800 kilobytes. You can kind of tell because it does not have the high density detector, little switch that is for detecting it. And this is obviously the type of drive you'd use on a Mac Plus, Mac 512, Mac SE. That's pretty much it, actually. And I guess the Apple II GS, the external 800K disk drive, would use the same mechanism as this. And actually, now I think about it, because I just unwrapped a hard drive, an Apple 3.5-inch, 500 megabytes, so much later than this. The computer that had this hard drive would have been high-density disk drive. Original Macintosh 2 also used 800K drives. I forgot about that. I think it was the 2X that maybe got high density, or super drive, or whatever Apple called it. So this hard drive is actually not even SCSI. This is an IDE hard drive. Still mounted on the sled though. That would have come out one of those Macs that used IDE, those Macs that you touch them and they break. The plastic that is, because they were very brittle. Incidentally, these floppy drives always have a broken gear. The eject gear always breaks in them. I do have a video on my channel somewhere, on the main channel. The eject gear is inside the underside of this PCB. There's a little gearbox for ejecting the drive. And I think I can make the drive go down. There we go. So the drive is down and you push this, it manually ejects it. Well, this motor turns a gearbox to do that eject. That always breaks. You can get modern 3D printed replacements for those. I do have a video on taking these apart and cleaning them and replacing the gear. It's old, but I think it's still valid. So if I remember, I'll try to link to that in the description below. But yeah, you can manually lower the disc there. Yeah, anyways, they're good, reliable drives. It's just, except for the drive gear, and they gum up. The grease gear gums up. Although this one's pretty good shape. Doesn't seem to be gummed up at all. It's actually pretty good. Interesting is the cover that's on here. I don't normally see a hole in it. Typically, it's completely flat on the top. I don't know which Mac this came out of, but it definitely came out of a Macintosh. Or maybe this was an Apple II disk drive, actually, like I said. One of the 3.5-inch drives would use this mechanism. It's kind of fun that this stuff's all wrapped up. It's like opening Christmas presents or something. Okay, this is kind of random. It looks like we have a Dell laptop floppy drive module for, you know, like a Pentium 2 era laptop. And then this is one of the floppy mechanisms, I suppose, probably similar to what's inside of this if we opened it up. So 3.5-inch floppy drive. Very similar as well to what you would find, it's made by Mitsumi. Very similar to what you'd find inside a USB floppy drive. And then the last one is another Dell floppy drive module. Very similar again, with a little thingy. You push this in, pop it out. I think it lets you pull the drive out. There's probably a release mechanism. I didn't really have any of the computers that would have been able to use this back in the day. I was a big IBM ThinkPad person. I don't know if I even had any laptops that had floppy drives internal. I think at the time when I might have had one, that was a laptop with a floppy drive. It was a Sony Vaio, and it was very thin. It was like magnesium, and it did not have any floppy drives in it, external floppy drive. And then all my ThinkPads, I think, were just optical only. Switch cameras here because it looks like we have more PCBs to open. This is for the Apple II as well. Precision Software of Florida, copyright 1983. What is this? A serial card or a parallel card? Well, let's see about Google Lens. An Apple II 80 column card? No. No, 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 that's impossible. This is not an 80 column card. All right, abandoning Google Lens, I typed in Precision Software Florida, and it likely refers to the Fingerprint Plus, which is what I talked about earlier. But again, I don't know if this is actually accurate when it comes to what the card is. Precision Software, so, well, the same company did make that Fingerprint card. Oh, that is it. Oh, I didn't even notice the header right there. Right, okay, well that is it. Okay, so it hooked up to your printer through that pin header, and then this, which, well, connected to that button, it had like, well, what looked like, and that's cool. Well, sadly, we're missing the header for that, and it's funny that I mentioned this card earlier when I was talking about the printer cards, the other ones we were looking at. It's possible. Well, it could be still in this package because we have more stuff to look at. But yeah, the whole idea of this was you had that button, which looked like a fingerprint, but it was just a button, and you pushed it, and whatever the computer was doing, it would freeze, and it would print out the screen. So if you had a game or graphics software or text on screen, you push the thing, and I'm assuming you set the switches to set your printer up, like Epson FX80 kind of thing, and yeah, pretty cool. Never used one of these, I just saw the ads for them. Quick diversion, I found a manual for the Fingerprint Plus on archive.org. It says it's a parallel and serial interface card with screen dump graphic utilities for the 2E and 2 Plus computer. You can connect a serial or parallel printer or modem, as well as capture any image from the screen of your computer and print it out the printer at a touch of a button. This is called screen dumping. It's like having your computer connected to a photocopier. Whenever there's something on the screen you want to print, just press the fingerprint activator button followed by the return key, and the image will be printed to your printer. It allows you to capture and print screens at the touch of a button without having to interrupt or leave the program. After printing the screen, just press the escape key and you're right back where you started. It also provides you the ability to enhance images, like you rotate, enlarge, crop, or use any of many other tools to enhance your captured image. Very interesting. Any image that you want to use in other programs can be captured by pressing the fingerprint button and saving to disk. In this way, you can create libraries of images for use in newsletters, diagrams, pictures, and much more. You can also use the Fingerprint slideshow program to create a computer slideshow of your captured images. The Fingerprint is also a great way to freeze game program while you answer the phone, print results screen with high scores, show parents or children the results, motivate students, and provide accountability for work done. It's also simple and fast to print information from your screen without having to use cumbersome print commands provided by some programs that entail many keystrokes. The Fingerprint Plus also has an added bonus of a typewriter desktop accessory which can be accessed at the touch of a button in the middle of any program at any moment. You can use it to type quick notes, add text to screen dumps, and send special printer commands to change fonts while inside a program. You can connect a parallel and serial printer or modem to the Fingerprint Plus simultaneously and thereby save money needed to buy extra interface cards and keep a slot free. Well, looking at the diagram, parallel port, serial port, I don't think we had a header there. ROM and the dip switches. Weren't the dip switches up at the top on this card? Indeed, the dip switches are for configuring various printers, and oddly enough, I guess, maybe you can call them and get other printers and set the switches or draw the switches in and then write them in. Curious. And it looks like the activator button was connected with a flat flex connector to that one little header there, and I guess it was flat so you could run it outside of your case. You close the case right on top of it. And I think I've seen photos of Apple IIs where people literally glued that button down right onto the computer case. Now it looks like once you push the fingerprint activator button, a menu will appear similar to the menu below. The menu will appear anytime you press the activator button from inside any application. And yes, this is the screen grab of the card that we're looking at here. It does have an extra header there with 4 pins. Is that the unused serial port? But the dip switches are up here, while in the diagram there, they're in a different position. So maybe this is a fingerprint non-plus. And here's a picture of the fingerprint plus. Yeah, clearly things are looking a little bit different there. We have 2 ROMs. I think this would probably be a ROM chip. A larger SRAM, 6116. I think that's larger than what we have here. And there's that serial port. There's also a GSI version that has a 6502 right on the cards. My assumption is this version probably works with other parallel or serial cards because it doesn't seem to have any header on it at all. And I suppose the CPU takes over the computer and maybe does DMA to your other cards. And those 2 pictures we just looked at are the only 2 that are on here. So this board is not either of these, maybe an older version. This is the board, the original fingerprint card, complete in box. And unfortunately, I don't see the manual for this. I just see a manual for the G+, the GSI, and the Plus version. So if you happen to know where there's a copy of the software for this and the manual, that would be very helpful. Just let me know in the comment section, please. All right, next up, we have an Epson APL board. I'm assuming this is for printing. I've really struck the mother lode for printer cards for the Apple II. I have more than any one human on the planet would need. So I don't know about this APL card, but I'm assuming this was bundled with Apple or Epson printers for printing on your Apple II to your FX80 or RX80 or whichever one it was. And this was the last card that was in that package. Asynchronous serial interface, model 7710. 6850, so I'm pretty sure that's a serial UART. Uses this to set the baud rate with these dip switches. And we have a missing IC that says RAM. Not quite sure I understand that it says RAM, but it says 74LS136, LS10 or LS09, LS03. Everything is labeled on the board, so that's kind of curious. Looks like we have a little bit of corrosion on that IC. It's hard to test these types of cards without the appropriate header because I don't know the pinout and it could well be custom. And ultimately, a bunch of companies were making serial cards like this, but the Apple Super Serial card is the one that everyone really supports. And the main reason why is Apple Serial card, for instance, can change baud rates via software control, while this, you need to have the right documentation and fiddle with the switches. So it definitely works, and I would think that you do PR number 2 if you have this in the second slot, and then it just, what you type ends up going to the serial port, and probably modem software would work with this as well. But ultimately, Super Serial card is the way to go, and there are now open source clones of that. Like there's one by Bradley Bell, which I've shown off on the channel before. So if you don't have a real Apple card, you can get one of the clones made pretty inexpensively. So I don't really recommend using cards like this just because you run into compatibility issues and they're just not as functional as the real thing. All right, we have another little bundle of cards. So let's open this, see what we have. Obviously, we have an Apple II theme going on here, lots of Apple II goodies. So I think that's what we're gonna have more of. And I can kind of tell on the top here, looks like we have a ROM card that was typically used in an Apple II Plus. So you could put your old Apple II ROMs into a card and switch those in via a toggle switch on the back, allowing you to quickly get to integer basic, for instance. And yep, that's exactly what this card is here. So that's one of them. And that toggle switch sticks out the back of the computer. It lets you switch back and forth between integer basic and AppleSoft basic, which will be on the motherboard after you upgraded your Apple II or II Plus to AppleSoft basic. So we have another one of those. We actually have 4 of these, and they're fully outfitted with the ROMs as well. Let's get that out of the package there, and we'll take a closer look at one of these. So you would upgrade your Apple II or II Plus to AppleSoft Basic, and you would remove all the ROMs that were on the motherboard, which would be all of these, including a blank space, and you would replace them with AppleSoft Basic ROM. So these would have come off, most likely off of an original Apple II, or maybe someone bought this card and it already had these chips outfitted on it. But with this card inside an Apple II, you put this in slot 0, and when you toggle the switch and you reboot the computer, you'll be running off these ROMs as opposed to the ones on the motherboard, and toggle switch the other way, and then you're running off the motherboard ROMs. The need for these cards was mitigated by having a 16K RAM expansion card in slot 0 also known as the language card. And the reason why that was called the language card is because instead of relying on physical ROM chips to run integer basic, you could load integer basic off a floppy disk into RAM, and the RAM on the language card could occupy the same exact space as the physical ROMs on the motherboard. So essentially you load the ROM images into the RAM card, and then you toggle a soft switch, and then the RAM is now acting as ROMs. You could even write protected. In the early days, people used these cards because it was just like 5 chips and a switch and some sockets, and then you could reuse your ROMs to switch between integer basic and AppleSoft Basic. But then once you got the 16K RAM expansion, you A, had 64K on your Apple II, but B, totally alleviated the need for this because, like I said, you would just load that stuff into the RAM. It was a very clever design on Wozniak's part to allow something in slot 0 on the Apple II and the II Plus to just replace the ROMs on the motherboard so simple and so easily. So it allowed this card to work, and the later RAM expansion card, which there were a million of those out there. Lots of clones, but Apple made one as well, but Microsoft one was super popular, did bank switching and stuff like that. But anyways, there are 4 of these cards, which is awesome because A, it is the original old ROMs as well. And I don't know, let's see if any of these are super old. And by super old, I'm talking about old non-auto start ROMs. Now, this all looks like this is from 1981. So I think these cards were basically sold by Apple. Even though it's got a date code of like 78, the date code's there. It's like 20th week, 1981. So this is not original. Wow, that chip has seen better days. These chips are not original, I don't think, from an original Apple II. Because that could have been what happened, is someone bought an Apple II, upgraded the ROMs, moved them onto one of these cards. But yeah, these are later ROMs. And yep, same thing here. These chips, none of these are old. Same with this last 4th card. So I'm assuming these cards probably all work perfectly. Just it'd be cool if one of these had the original Apple ROMs. I might try to take one of my 2 Pluses and convert it back into an Apple II. ROM card. All right, there are 2 more things to open. One of them says Mitsuba add-on card, monochrome graphics and printer adapter. So the box, at least, is for the IBM PC. Doesn't really say anything else other than that. Do we have the original card in here? Maybe. There it is. This is definitely an ISA card. Okay, so this card is an ISA card. But this is not a monochrome printer adapter as it said on the box. And one big giveaway is we have a 65C02 right there on freaking board. In fact, there are 2 of them. What are 2 chips doing on there? Well, from my understanding, this is the Diamond Computer Systems Trackstar. There it is, and the FCC ID Trackstar. And this connector here, for instance, is for an Apple II floppy drive. And yes, this is an entire Apple II on an ISA card. So it like literally lets you run Apple II software on your PC. I've seen videos about this, but I've never used one myself. We got RAM. We have 16K right there, those 2 chips. I'm pretty sure these are 64K chips, 464s. So 2 of these is 64K. So we have 128K plus 16K. We have a whole slew of PALs. All of these are PALs. There's our 6502, 65C02, sorry about that, and another 65C02. We got 2 ROM chips, various TTL logic. Continuing over on the board, we have a PAL that's actually soldered onto the board, along with one in a socket down here. I think this is a header that would connect to your CGA card that would essentially inject Apple II graphics into your CGA output. So this goes to your normal CGA monitor, you see Apple II graphics, and this is a pass-through for CGA from your main graphics card. And my assumption is this is a normal 19-pin Apple floppy drive port, and that is for an internal port. And this, not sure. So I knew all along, by the way, opening up this stuff, that there was at least one of these cards in this package from Walter. So this was the star of the show, so to speak, and I'm definitely going to try this out in this video. We do have the manual for the Trackstar Plus, Diamond Computer Systems. I think this is the same Diamond, by the way. They made like Diamond 3D and all those Voodoo cards and stuff like that. And the manual talks about the various ports. So yes, joystick connector up there. Video input. Ah, okay, that's the video input. Video output. Wonder what that's all about versus this connector. Okay. Apple Unidisc. That is external disk drive, internal disk drive connector. Yes, okay, so there's some like video adapter cable. I think it is just a normal CGA connector on the back of this card, typically. Now, this card, by the way, has been fully reverse engineered, and there are replicas you can get of these. You don't have to have one of the originals, and there's no benefit to having an original versus one of the replicas, in case you are wondering about that. Technical overview. The Trackstar Plus is a 65 CO2 parallel processor board. It may be installed into an IBM PS2 model 25 or 30 and will provide you with the ability to run Apple software on those machines. The Trackstar Plus supports most Apple features and contains enhancements not present in the original Apple system. 65 CO2 microprocessor, 1 or 2 megahertz operation, 128K of RAM, 1480 column, low res, high res, and double high res. So this is obviously emulating a 2E. Support for 4 floppy drives, hard drive, local area network, serial and parallel ports, Apple compatible 5¼ inch disk drive port, 2C compatible game port, and a Thunder clock compatible Apple clock. What's interesting is that the manual is talking about specifically using this in an IBM PS2 model 25 or 30. So this might not be quite so easy for me to test, because obviously we're missing harnesses and things, and it expects to be in a PS2, not in a regular clone. I was thinking this would just work in a normal IBM PC clone, and that would be a CGA video output or the Apple II video output. But it seems like it might be a little bit more involved, because we're missing all the cables, and I'm sure I can find the software online. I just don't know the idiosyncrasies required for making this work in a normal IBM PC versus the PS2. Okay, well that is a very interesting and very exciting card, but let's see what's in this thing. Is this an expansion module? It says expansion box for the Laser 128. That basically gives the Laser 128, which looks like an Apple IIc, I think 2 card slots for normal Apple II cards, like sound cards, disk controllers, whatever. Oh, yes, that is exactly what this is. How cool is that? In original packaging, no less. So the Laser 128 is an Apple II clone. They made a few different versions. I have an EX2, I think it is, which has accelerated processor, maybe 4 megahertz, and some other cool features that make it a bit better than the Apple II, to be honest, but it does not have card slots. Well, it does. It has 1 card slot on the side, and this thing plugs into the card slot right there, and there's a ribbon cable, and then you have this box. And inside this box, I don't know how many card slots are in here, 2 or maybe 3 even. It's big enough for 3, and it's got various ports on the back. So if you have specific Apple II cards that aren't built into the Laser 128, like it has serial, parallel, floppy controller, 80 columns, you know, all that kind of stuff. But if you want to use, say, a light pen or something else that's not normal, you can put it in this box and plug it into the side. And I've never seen the box for this expansion unit. It just says expansion box inside, VTech. And inside there, in one of the pieces of foam, there's an external power supply that powers the box specifically. So it needs extra power to run those cards. 10 volts DC, and seen better days, unfortunately. Considering this was inside packing foam, I have to imagine this broke apart from stress of just like the way this was assembled. Looks like there were 4 screws that held this together originally. Those 2 are still in there. You can see the standoffs, or what's left of the standoff is still there. And then those 2 just completely snapped off, and the screws are still in there. We can clearly tell by the fact that this thing doesn't even have a voltage regulator in here. It's just a bridge rectifier and there's a little tiny capacitor down there, and then this larger cap. This is unregulated, so I think that means you can pretty much feed whatever into this thing, and you don't have to be too concerned that it's not exactly the right voltage. At least we know the polarity though. Center positive, so that's normal. But yeah, I bet you 12 volts or 9 volts probably all works just fine. And inside here is probably a simple linear regulator that just brings that external power supply down to 5 volts, which is going to be fed to the cards that are plugged into here. And the minus rails and other rails are going to feed off the Apple II computer. They don't take much current. You need all the current on the 5 volt rail. And it looks like it's never, ever been used. There's an on-off switch back here as well. So cool. All right, I'm going to take a quick break to do a little bit of research to figure out what it takes to get this working in a regular PC, you know, my bench lab PC, as opposed to a PS2. I don't feel like busting out the PS2, and then I'll have to figure out the pinouts for the video pass-through stuff. That should be relatively easy. because, yeah, I want to see this thing working. And why does it have two processors? Why are the two 6502s on there? Is that because it's runs at 1 megahertz or 2? Anyways, lots to figure out on this thing. I'll be right back. All right, it's the next day, and I've done some investigation, and I have made a cable for the Trackstar. Turns out I was a little off with what the different ports are on the card. Let me explain what I figured out. So the Trackstar Plus, which is what this is one of the most fancy versions of the card. It's an Apple IIe clone, although it's missing mouse text support, but I think it's generally an Apple IIe otherwise. So 128K, double high res, all that kind of stuff. From a port perspective, this is the floppy drive port that plugs into a real Apple II disk drive. This is for an external Apple II disk drive. This port is actually a VGA port, and it is just a normal HD15, and it is the output for the video. Now, the odd thing is this is designed to work inside a PS2 Model 30 and I think 25, and it turns out that this is the video input into the card, so this would come from your motherboard, and I've gone ahead and made up a cable that is VGA input. And on the Model 25 and the 30, you would plug in the original cable that went to the motherboard that fed the VGA connector on the outside of the computer. It would plug into this port. So this is the video output, which I've since written on the board there. But it turns out that these are both video outputs, and this just allows you to plug a monitor directly into the card. Now, to have the pass-through, which is the PC video, to work and then switch to Apple II, that's where you would connect up this input. So this card shipped with an extra little cable that plugged into this and then would plug into the motherboard, and that would feed the VGA signal into the card. The card also came with a little cable and a 9-pin connector that connected to this connector, and that would allow you to use Apple II joysticks. I don't think a mouse, but at least regular Apple II joysticks. Now, I found all the information I needed on the Trackstar cards from this excellent website by Brandon Cobb. It has all the information you could possibly want to know about the version 1, version 2, 128E, and then the Plus, which is this variant, along with scans of all the manuals, interviews, software disk images for all the different cards. Even the ROMs and whatnot are available to download, and all the dumps of the PALs and the GALs that are on these cards. There's also a bunch of software, which I've also copied onto my bench PC here, that we can test out. This is Apple II software that's already been converted into the disk image format that this Trackstar Plus card can use. Now, as far as I can tell, the Trackstar E and the Plus added the ability to use these disk images on the MS-DOS size, and it even allows ProDOS virtual hard drives. So that's freaking awesome. That's right, the Trackstar Plus and the E can copy physical disks to image files stored on a PC to quickly and easily use your favorite programs without needing the original disks handy. As well, ProDOS virtual hard drives can be created and used up to 10 megabyte in size, an amazing innovation. It says here that the Trackstar Plus can optionally connect to the PC 5.25 inch 360K drive in order to read and write real Apple II disks, but apparently that doesn't really work that well. And what's odd is I don't see how that could connect up on this card. I don't see any types of extra connections. So unless it does it through software or whatnot, I'm not totally sure. But notice the last line, the Plus outputs video directly to the PC VGA monitor, and a custom cable intercepts your PC video, which is then output by the Trackstar itself. So that's the switching between the PC or IBM PC mode and Apple II mode. And then the Apple II sound, meanwhile, is routed through your PC speaker. And it must be done with software because there's no physical connection for that. Now, under scans, there was a VGA cable pinout, and this was created by Korrey Moore at some point. And this was the information I needed to be able to make the cable, the VGA input cable for the card. Now, one of the things is it doesn't list what the signals are, just these color codes for how you would hook it up. So I went ahead and created a new interconnect, as you see here, that just lists the actual names of the signals. It's just a little bit easier for me because the VGA cable I was using, I just had a cut cable from somewhere. The colors didn't match what was listed on this one, and I just work better knowing the various signals themselves, like RGB, etc., etc. So I set up my lab PC at 36SX, and one thing we have to keep in mind is that you do need to have 8-bit slots because the actual Trackstar card, the PCB, comes down and won't fit into a 16-bit ISA slot. I just wanted to make sure I got everything working, so I didn't have any issues with the XD IDE or any of that stuff. So this boots up, and I already copied the Trackstar utilities onto my compact flash card. And here are those utilities I downloaded from the website. There's TS Utilit. Trackstar board does not respond, so of course it's not installed in the computer, but I think that's what you use to kind of get it set up. And then there's Star, and I think that starts the actual Apple II emulation, like boots the Apple II. Included with this, there is a README that says use the TS Utilit to configure your Trackstar operating environment, and then Star to launch the Apple IIe. What's next to do is get this thing plugged into this computer And let's see if, well, the computer even boots with this installed into the motherboard. Trackstar is installed into the machine. I won't hook up the video signal yet. We'll just leave that there and let's see if this works. Could have a shorted tantalum. Who knows? I'll step back. Okay, system powered on normally. You can see the pink power LED. Oh, all right. Well, the Trackstar board does not respond. Consult with the dealer or Diamond Computer Systems. Let me quickly consult the manual because maybe I need that sys file. It says the installation is self-explanatory. Once the board is installed, you just run tsutility. Interesting, that's a different name. There's a screenshot of it. System configuration. Yep, some disk utilities. Everything in here is pretty self-explanatory. There's not a whole lot to it. It's just telling you how to deal with the fact you're missing some of the keys. So thinking about what might be wrong here, I think there may be a problem with, well, the fact that I'm using a 386, so that could be an issue, but more likely it's probably that this uses some memory mapped IO space in the middle of the upper memory. And of course I have an XT IDE card in here, well I have the ROM in here, that is taking up some of that space. It could be conflicting with this thing. And reading through the manual, it doesn't say anything about what memory locations or IO addresses this card uses. There's nothing about that. And there are no configuration jumpers either, so I don't think there's anything you can change. So I just moved the XT IDE, I think it was at C800, I moved it to D800. Oh, there's no video coming out because I don't have it plugged into the VGA card. There it is. So yeah, D800. And the other thing that might be causing issues is like HSYNC sys or EMM386. So let's just abort those. And the same error, Trackstar does not respond. And one other thing I can configure on this computer is I can adjust the AT bus clock, but it's already set to the slowest, which I think is correct because this thing probably is running at 40 megahertz. No, this thing is actually running at like 18 megahertz, it looks like. So that AT bus clock is actually a little bit slower. Let's just put this on auto config, see if that makes any kind of difference at all, but I am sure not. I guess I could try changing the CPU to low speed. And it says 16 megahertz, but that's weird because the crystal is 36. I'm pretty sure 36 divided by 2 is 18. It would be 32 megahertz if we wanted to have a 16 megahertz clock. Maybe the BIOS does not support showing 18. Okay, things look real slow here, which is good. Want to slow this computer way down. Oh yeah, super duper slow. Let's take a look back at the website. Trackstar was engineered to work with machines using a 386 or slower. High-end machines may need to be slowed down. Okay, well, we've already done that. And that's it for the tip section. It's talking about the quad link. We don't have a quad link card. We just have the Trackstar. I can feel that this board is pretty warm. Like these chips have gotten warm. I'm just gonna give every socketed IC a little bit of a push. Never know. Maybe we just have a bad connection. The only thing I haven't done is connect the video input into the board. Let's just see if this works now that I push down all those chips. Okay, TSUtil. Oh, it worked. All I did was push down those chips. That's it. Well, color me shocked. Deoxid that socket, I guess, right? System configuration, configure the disk drives. Let's just leave this as is. Function key programming. Catalog, B-run, whatever. Okay, fine. Let's exit that and let's try running it. Boot from A or boot from external disk drive. Please insert diskette that you wish to run in drive A. Oh, Trackstar format. Okay, I see it. This has to actually be on a disk in the floppy drive. That's kind of interesting. I figured we just load it off the hard drive. Maybe I'm getting ahead of myself, but I'm just gonna use this MyTac clone floppy drive and we're just gonna plug this into the Trackstar. And that way we can try to boot some actual real Apple II software. I don't have the pass-through VGA connector hooked up, so I'll just have to move this over to there when we power it up again. Okay, here we go, 3, 2, 1. Okay, everything powered up normally. I forgot to abort the startup config, which means we have EMM386 and HSYNC sys working. So let's see if that messes things up. Oh, no, it still works. Okay, 6, quit. Okay, so we're gonna boot from the external floppy drive. And please insert a disk. So we have Fat City here. And hit enter when ready. Oh, the disk is doing stuff. Let's move the cable over. Oh, language arts. All right. It's freaking booting. Oh, this is actually double high res. Wow, that looks freaking terrible. Absolutely terrible. But it's working. I think this is the game Kicks. Now, what it's doing wrong, in my opinion, and I guess this is just the way it works, is when you have the vertical bars, which are artifact color on Apple II, instill... Oh, right. I have no idea how to reboot the Apple II here. What was happening is the vertical lines, the artifact color, when you really decode those for RGB or VGA in this case, because this is upscaling, you really need to double the pixel. So it leaves the vertical lines and just applies a color on top of them, which is not really the right way to do it, but it works. It's just the color is never going to look good because it's not going to be solid. All right, so you get to the menu by hitting F1 and escape. And of course, now we have to plug back into the video or VGA connector on the other card. I really need to get the pass-through hooked up. Okay, there it is. Reset. Let's look at the control keys. F2, color enable or disable. F9 is open Apple. F10, closed Apple. And Alt1, Alt2 switches between normal and double speed. So there's no reset. Interesting. You have to actually come to the menu to do the reset. Anyways, the reason why I wanted to reset is I wanted to switch back and boot the other side of the floppy. So we're going to hit R for reset. We have no video. Oh, there it is. Fat City. Look how terrible the color looks. So F2 turns the color off and on. Oh, yeah. It's just not filling in the color properly. We'd be hearing the beep speaker, I assume. Also interesting is like the letters should be, the big Fat City letters or, you know, keyboard joystick, that should be orange and it looks like it's in red. And this is VGA, like it's hooked up to a VGA monitor right now. Therefore, there's no reason they could have picked the colors that were exactly the same as the real Apple II. Yeah, it's disappointing. Let's hit caps lock. I think you got to have uppercase for this to work. Adrian, which round will you start in? Let's just start in round 1. Interesting how like the video is like shifted up and over to the side, but it does work. Yeah, there it is. We're running Apple II software on a freaking IBM PC. I just wish the color looked a lot better. It just, instead of like these vertical green lines or blue or red or whatever, it needs to fill those pixels out horizontally so you don't see the lines anymore. Yeah, that's a really cheap way of doing it. I have to admit, I mean, obviously it works, but it just looks freaking terrible. Now, of course, I'm capturing the video here through my Extron, so the video, the fact that it's all like shifted around has, well, it's not the fault of the Trackstar. I guess it's just the way its video output looks. Well, I'm going to stick in a copy of Locksmith. See if that loads. Hit enter. It did load, but the font looks so strange. So let's do U for utilities, V for verify. Just to make sure I can verify this disk. This is the actual drive. Looks good. Now there's some scaling artifacts. That's the scaler. It's not set up for the resolution that's coming out of this card. Well, it seems like there's a bunch for me to figure out on how this works exactly, and I would like to because I kind of want to build up an IBM PC with maybe a 36SX motherboard in it, like a little case, with this Trackstar in it, because it would be really fun to bring this up to meetings and have it playing Apple II software on a PC. Just like people will look at it and be kind of confused. In fact, I'd be even more confused if I plugged in my external Commodore 1541 disk drive into the Trackstar for loading Apple II software. That would really confuse people. It's a bit of a shame that the color rendering on this doesn't look that good. I wish it did a better job at filling in those pixels so we didn't have those vertical lines, but I guess it is what it is. And maybe when you're looking on a real CRT, it looks a bit better than it does through the scan converter. But this is pretty awesome that this works, and I guess the fault was pushing down the chips into the board, and that fixed it. I still don't know if this is using just I/O addresses on the PC or if it's using memory map space in the upper memory. So was there an issue with my XT IDE ROM conflicting? I don't know. I changed that first. Still didn't work. It seems to work fine with EMM386 and HiMemSys running. And I think this motherboard right now is set for a slow clock speed with a slow ISA bus. So I'm not sure where the limits or the upper limits are for this card working. That would be something to figure out in the future. I'd like to kind of figure out how this disk emulation stuff works, because it would be a lot easier than having the physical drive. Although the reality is having an Apple II disk drive hooked up is not that difficult either, and I have plenty of Apple II disks, and I haven't really tested my little pass-through cable here, but I'm sure this thing works totally fine. And this overall is a relatively slick solution, I gotta say. And I do wonder if it's possible to swap out the ROMs on here with an actual Apple II ROM set from an Apple IIe, so you have full Apple II compatibility as opposed to these like kind of clone reverse engineered ROMs that are on here. So if you happen to know about the whole ROM swapping thing, let me know, and maybe the mouse tech support as well. It'd be really cool to have this thing like fully operational. And I'm gonna have to do a follow-up video once I figure out more stuff on this and maybe show the final build with all the capabilities that what this card can do. It's a very, very cool card. And Walter, thank you very much for sending this in, along with all those other 2 goodies, like the laser expansion interface, all those other Apple II cards, and those other parts and that CPU accelerator. There is lots of good stuff to be had here. So that's going to be it for this video. Thanks very much for watching. If you liked it, thumbs up. If you didn't, you know what to do. Huge thanks to my supporters. Name to go up the side of the screen, and all the other YouTube junk. And that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.